You calculate the time period. Now, generally, these questions here, when it comes to time period, it's mainly the two compound interest formulas, the one for appreciation and the other one for depreciation. So the formula that you are going to encounter when it comes to calculating the time period, for now, I'm talking about for now. So one is A equal to P times 1 plus I raised to the power of n, or A equal to P times 1 minus I raised to the power of n. So those are the two formulas that we are going to concentrate on. Right? Remember the second formula. I need you to pay attention. Put the other one away. Right? The second formula, this one here, is called the reducing balance formula. This one. Okay, let me recalibrate now. So I was saying, right, this formula, this one here is called the reducing balance formula. Okay, and this one is the appreciation. Right. So for this, the question says, the filler deposits 100,000 into a savings account. Now, because of this word savings here, it means you are most likely to use the first formula, the appreciation one, whereby the accumulated amount will be greater than the principal amount. Right? The interest rate is 12%, per annum compounded quarterly. How long? That's time now. And usually the time will be in years. Okay? How long will she have to wait to have 180,000? So, how long is she going to wait for her to have 180,000? Now, because of this word compounded, that's why we have to use the first formula. Also, because of that word savings. Right? You can make a mistake of using the second formula here. So you need to be very, very careful. Right? So first thing, we list what we are given. Our A is 180,000. Then P is the amount which was deposited at 100,000. And then N we don't know. The interest rate is 12% annum compounded quarterly, so that is 0.12 over 4. Right? That's where you start. Then write the formula. A equal to P times 1 plus I raised to the power of n. Right, then you substitute. So we have 180,000 is equal to 100,000 times 1 plus 0.12 over 4, all raised to the power of n. Okay, that's what you're supposed to have. So correct substitution here. If you've got this step here, correct substitution, the correct formula, you give yourself a tick there. Then the next thing, we divide both sides by 100,000. Now, if we divide both sides by 100,000, we get 100,000 divided, so 180,000 divided by 100,000 is equal to 100,000 divided by 100,000. Okay, this will be obviously times 1 plus 0.12 over 4 all raised to the power of n. Right? Allow me to just erase what's there. Need to erase this because I need that space. Right? Then, when you do your division on the left, you are going to end up having 9 over 5 is equal to 1 plus 0.12 over 4 all raised to the power of n. Once you get to this step, your knowledge of logarithms will be required once you get to that step. Now, there are two ways, but I feel like I just need to show you maybe one way to avoid unnecessary confusion. Right? So by now, from yesterday's lesson, right, you should know that we are trying to calculate n. So you drop down the n, right? This 1 plus 0.12 over 4 becomes your base. So it will be the logarithm of 9 over 5 to base of 1 plus 0.12 over 4. You can put that in brackets, but be aware that it's a base. The number that we are trying to find its logarithm is this one here. That's the number we are trying to find its logarithm. And you must have a calculator that can allow you to put the base. If your calculator does not have that function, then buy a new one. All right? Any questions so far? So we are here now, right? I'm going to put that in the calculator. So you go to this button here, click that, then let's put the base. The base is 1 plus the fraction option. Now, it's always wise when I'm doing it, you are supposed to be looking here. And I don't expect you to be doing much. So that is 1 plus 0.12, because I gave you an opportunity to do it all over 4. Then let's put our number that we are trying to find its logarithm. It's a fraction, so that will be 9 divided by 5. That's what
you give it a decimal.
Wait. Right. So that will be the answer. I don't encourage you to convert this number here to a decimal. Okay. Why are you scared of working with it as a common fraction? Because your calculator can accommodate common fraction. There is no need to convert it to a decimal. Right? Your calculator has got the fraction option. Use it. Right? Because if you convert to a decimal, sometimes you might end up being forced to round it off, and that can exaggerate your final answer. So work with it as a common fraction. So this would be 19.8, okay, 19.89, okay, 19.8. That's the value of n. Remember, that's the value of what? N. In terms of the quarters, please, these are not months. These are not months. Okay, I need to emphasize that. You see, because of this word here, quarterly, the n that you get there is not the number of months, and it's not the number of years. It's the number of quarters. Okay? Because our compounding period is quarterly, therefore it's the number of quarters. Right? So to find, so here I'll say n is going to be equal to, right? Let me just write it. It will be 19.8853. I'll say 19.8853, then I'll put dot dot. Right? You can do that because that's not the final answer. The final answer, you have to divide this answer here by 4 to get the number of years. You divide this answer here by 4 to get the number of years. So, if we divide that answer by 4, we will get 4.97 years, which is approximately 5 years. Right? So, I'll write 4.97 years first. Then, I'll say n is approximately 5 years. This is the, you can use that sign as approximate, or we can write it like that. Alright? Then it's not that difficult. Right, let me move on because I need to start notice. Right? Well, it's this will be generally maybe 3 months. It's not a range apart. So you might get a correct formula, correct substitution, use of logarithms, yeah, and the final answer. So it should be 3. Right. The use of logarithms there is a very important skill. Right. Okay, the next question. Right. How long will it take for the value of an investment to treble, that is 3 times, if interest is calculated at 22% per annum compounded semi-annually? How long, this is time, will the value of an investment take to treble? Right? Now, in this case, we don't have specific values for the initial amount which was invested. Right? Because it's an investment, we are using the appreciation formula. Because it's saying what? It's an investment. Right? We're using the appreciation formula, and obviously it's the appreciation formula for compound interest. Right? So we've got 22%. Now here, what you do, since you don't know the initial amount which was deposited, you can call it X. Or you can give it any letter you like. So I'll say my P is going to be X. My A, okay, after it has tripled, that will be 3X, right? Then my interest rate, that will be 0.22. It's semi-annually, which means 2 times a year. Divide that by what? By 2. And then your N, you don't know that. Right? We're going to use this formula A equal to P times 1 plus I raised to the power of N. Right? Then you substitute where there is A, you put 3x there. Where there is P, you put x. Then where there is I, it's 0.22 over, now that will be over 2 raised to the power of N. Right? Now, here, you don't need to get confused. Right? Because of the fact that we have one term on the left, one term on the right, this x here, those two x's, they cancel out. Right? After they're cancelled out, you end up having a 3 on the left, then 1 plus 0.22 over 2, all raised to the power of n. Now this becomes an exponential equation, right? This 1 plus 0.22 over 2, that's your base, right? We are trying to find n, so it becomes n equals the logarithm, okay? That's 1 plus 0.22 over 2, and the number that you're trying to find its logarithm is going to be a 3. Right? Then you check out your calculator. Check out your calculator. Logarithm function, the base, 0.22 over 2. Right? Then you get 10,527. Now, that 10,527, it is the number of, right, well, what I can say is, it is the number of 6 months, total number of those 6 months. That is how many times the interest is going to be compounded. Remember, when you say semi-annually, we are saying the interest is compounded after every 6 months. Right? So we want to know how many 6 months are there. The total number is going to be 10,5 something. Right? So I can write that it is n equal to 10,527. So n equal to 10,527 dot. Then I need to determine the number of years by dividing this answer by 2. I have to divide by the compound period, which is 2. So we divide this by 2. And then you get 5,26 years. Okay? 2 decimal places. So that will be 5,26 years. 5,26 years. And so this will be the final answer.